example 4, graph the composition of the translation of EFG 3 spaces left and 2 spaces down with the reflection of its image across the line x equals 1 to create triangle E double prime, F double prime, G double prime. We're composing, so we're doing 2 transformations. So when I start off with the second one, I always start off with the second one here. When you see a composition, the second one happens first, because it does. I'm going to translate triangle EFG, which is graphed very nicely right there. We're going to go 3 spaces left and 2 spaces down to create E prime, F prime, G prime. So, if I'm an E and I go 3 left and 2 down, that's where E prime is going to be living. If I take F, which is here, go 3 left and 2 down, that gives me where F prime goes. And then if I got G, I go 3 left and 2 down, that's where G prime goes. Okay, so to reflect any type of polygon, simply reflect the vertices, or I should say translate. Translate the vertices to do a translation to get each image of the pre-image EFG. So E moves to here, F moves to here, G moves to here. That makes E prime, F prime, and G prime. As with every transformation we've done so far, when we actually perform the translation, we're going to draw the picture of the translation by connection dots. E prime goes to F prime. That's not a line. It's weird. And F prime goes to G prime, and G prime goes to E prime. So that blue figure right there represents the translation, 3 spaces left, 2 spaces down, of the original figure EFG.
We already did this in the last.
Did we? With a rotation too? Like a composition of things?
No, I don't think so.
Isn't that basically the same thing?
Well, it's stuff we've done before, but now we're doing them together at the same time. Right,
Now
so we're doing
drawing
more than
one
one.
extra straight line.
So, is everybody comfortable with what I've done so far? Performing the translation, which is what we did yesterday, right?
Yeah.
Then, we're supposed to reflect. We're reflecting this. So, this right here is E prime, F prime, G prime. So what's circled in blue here makes this triangle here. We're reflecting that triangle to create the second triangle, E double prime, F double prime, G double prime. We're forming 2 transformations, so we're getting double primes on our final dots. And as just was discussed a moment ago, I got x equals 1 as my reflecting line. So if I want to graph x equals 1, that's just a vertical line. I usually do my reflecting lines dotted. Vertical line at x equals 1. Okay, this is the line I'm reflecting against. That's my mirror. And what I'm reflecting is triangle E prime, F prime, G prime, which is currently all left of the mirror, so its reflection is going to be all right of the mirror. And I want to take each vertex and I want to reflect each one individually to make this E double prime, F double prime, G double prime. So, if I look at E prime, which is currently located right here, I want to see how far away from the mirror it is. So, it's just a horizontal, it's a vertical line here, so I'm moving left and right to see how far away from here I am. 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the left of the mirror. So I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the right of the mirror to get E double prime.
Wait, why 9?
Because here's the mirror right here, and here's the dot right here, and they're separated by a distance of 9. So again, however far away from the mirror you are on this side, its reflection is going to be the same distance away on the other side. And since the mirror is a vertical line, we simply have to see a horizontal distance away. If the line were slanted, then we'd have to do some midpoint finding. It was a little bit more challenging to do. All right, but again, for a vertical reflector, we simply count the horizontal distance and go the opposite direction, the same distance. All right, so the same idea for the other 2. If I look at F prime and G prime, F prime currently is 1, 2, 3, 4, 5 spaces left of the mirror. So I want to go 1, 2, 3, 4, 5 spaces right of the mirror to do F double prime. And then G prime is 1, 2, 3, 4, 5, 6 spaces left of the mirror. So I want to go 1, 2, 3, 4, 5, 6 spaces to the right to get G double prime. And then I connect those dots with a straight line. as before. So E prime goes to F prime goes to G prime, and G prime goes back to E prime. And that's my final after both transformations happen. So first I translated it, then I reflected it, and I ended up here. My final image is right there. It says identify the coordinates of the vertices of the final image. So in other words, after you've done all the transformations they tell you to do over here, what are the coordinates of these 3 points? So I identify the 3 points. I've got E double prime is something, F double prime is something, and G double prime is something. Just identifying coordinates of points. So E double prime is from the origin. Here's the origin right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma 2. F double prime is right here from the origin. 1, 2, 3, 4, 5, 6 right, 1, 2, 3 up. That's positive 6, positive 3. And G prime is down here from the origin. 1, 2, 3, 4, 5, 6, 7 right, and 1, 2, 3 down. That's 7, comma negative 3. Those are the coordinates of the vertices. A moment ago, Jocelyn said, what if we did it the other way around on the last problem, right? What if we switched the order of this stuff? So pretend that we do that. So this is it, the end. That's the final image. Those are the coordinates of the final image. All's well, that's the end of this problem. Okay. The reason it matters what direction we do these things in, suppose we did the reflection first. And let me just take a look at point E. I won't do all the 3 points, but just look at E. If I reflect E first, here's E. It's 1, 2, 3, 4, 5, 6 away from the reflecting line, right? If I reflect it, it goes 1, 2, 3, 4, 5, 6 spaces. This is where E prime would be, right? For the reflection. And then if I perform the transformation, 3 left and 2 down, 1, 2, 3, 1, 2, this is where E double prime ends up. It's in a different spot than E double prime, right? So if you do the translations or the transformations in the wrong order, you won't necessarily end up in the right spot. So again, make sure you do the second thing after the, so what, if you see a composition symbol, do this first, do this second. Make sure you go in the right order or else you'll be in the wrong place after you do both transformations.
Wait, how do you know what that green line does?
What green line? This green line?
It says x equals 1.
That says x equals 1, right? And what does x equals 1 make? A vertical line, right? So anytime you see x equals number, always vertical line. Anytime you see y equals number, always horizontal line. All right?